Okay, well, thanks for hanging in there. This is, I guess, the last session before, I think there's a plug fest going on after this, and then a couple other items this evening. My name is Cameron Brett. I'm with Toshiba officially, but I'm also a board member of the SCSI Trade Association. I've been with SCSI Trade Association for about 10 years now, and just because For full disclosure, I also sit on the NVMe Marketing Committee as well, so I'm not necessarily here to take one versus the other, but I definitely want to see both succeed. I've been in the storage business since 1991 at a lot of the companies in the Valley here, Adaptec, Broadcom, where QLogic became Cavium, became Marvell, and PMC Sierra, which became Microsemi, is now Microchip, and so it's definitely a lot of consolidation. Has everybody been through at least one consolidation move here? Yeah, I think so. Before I dig in, I just want to kind of get a pulse of what the people in the audience who is interested or designing around SAS arrays today. A few. How many around SATA? This is kind of like active development or things. Okay. How about NVMe? A few more hands. There definitely seems to be more, I guess, momentum, I think, around NVMe. SAS has been around a long time. It's very, very well understood. Okay. Well, today, I'm not necessarily picking one versus the other, but kind of showing a kind of a comparison of common systems and deployments today between the three interfaces. And probably the unfortunate thing is that SATA is going to come up on the short end of the stick here, I think. As we all know. So this is some information from IDC. This is a snapshot of the interface split. I mean the array type split between all flash array in blue. You have all hard drives here, and then the hybrid up here. In 2017, the AFA market was about $6.2 billion, which is not bad. That's just for AFAs. In Q1 2018, the AFA market is a little over $2 billion, so it's definitely on track for continued growth. Here we are in 2017. It's roughly an even split between the hybrid, hard drive only, and AFA. But as you can see over time, as IDC sees it, the AFAs are definitely growing the fastest and will become more than half of the array revenue by 2022. We can see that the all hard drive array is kind of going by the wayside. It's not going to go away because there will always be room for cheap storage, archival. But the hybrid array is where it's still going to remain kind of steady, but there's kind of a slow decline over time. So here's a statement here. The SAS is the main enterprise storage interface. If we look at the market numbers here, units are over there on the left, and capacity is over on the right. So if you look at the big blue bars here are a combination of SAS and SATA hard drives. So there are definitely going to be a lot more SATA hard drives in there. And then if you look at the lower, the two blues, the smaller one in between here, those are SAS SSDs. So how is SAS the main interface? Well, when you really get right down to it, it's the SAS infrastructure. The SAS infrastructure really supports not only SAS, but largely supports most of the SATA deployments. So the SATA drives go into basically a SAS-enabled array in many cases. So the infrastructure in for units between SAS and SATA, greater than 70% of the units sit behind some sort of SAS infrastructure. And then if you look at the capacity, that number, from a pure petabyte standpoint, that number grows to even greater, expected to be greater than 85% in 2022. So I don't know if that was an interesting surprise to anybody, but SAS, most of the storage sits behind SAS infrastructure today. So I'm going to take a look at the different interfaces and look at a common, kind of typical deployments for them built on SAS, arrays that are built on NVMe, and arrays that are built on SATA. So as we go through these slides, I'm going to try to find kind of common case. There's going to be lots of scenarios where you can say, oh yeah, but we do this, or that you can do this or that. There's lots of ways that you can find ways to go off and do interesting and unique things. But I'm trying to kind of depict kind of the more common deployments. So these are not necessarily absolute statements. There's lots of ways that you can deploy things. So with that being said, let's dig a little bit into. This is not meant to be a history lesson here. I'm sure a lot of you already know SAS. SAS itself is an extension of SCSI, which was born in the mid '80s, and has the data rates that have gone through parallel SCSI up through serial attached SCSI 3, 6, 12. 24 gig SAS is coming soon. How many of you have heard of 24 gig SAS? Okay, so actually one more quick question. How many of you are like vendors in the industry that work at a tech company building storage related products? Okay, and how many are more of the end customer types? Okay, well good. We've got a good nice mix in here. SAS, I'm not going to go through every one of these. That's not what I want to do here. But it's really meant to kind of show some comparison level here. And SAS, people think SAS is going away. Actually, it's not going away, at least not yet. There is a roadmap that goes for probably through my retirement. So cable lengths can go up to 100 meters, that's from like data center to data center for optical, and 10 meters on copper, so within a data center room. One of the best things about SAS is that it supports both SAS and SATA hard drives and SSDs, and that's one of the things that gives it so much flexibility, and why it is so widely used, and why those numbers, the 70% and 85%, are sitting behind a SAS infrastructure. The SCSI protocol is being used in many other types of storage that you're familiar with. And then there's, interestingly enough, from a SAS device standpoint, actual SSDs, there are not that many companies that are really making SAS and being successful. Most of the customers for these are going to be your enterprise businesses, and they buy through classic OEMs, and those OEMs have very strict requirements. So as you can see here, there's just a handful of really viable SSD suppliers for SAS. And then just one more market data point. SAS, between SAS hard drives and SSDs, been about 3 million hard drives sold in 2017, and a little over 30 million hard drives that have been sold. So over 33 million drives sold, and SAS is not really expected to decline in any significant fashion in the near future. There actually are some new developments happening in SAS that'll help extend its life. Question?
So for that 3 million SAS SSD, do you have like a further breakdown of how many 6 gig SAS, how many 12 gig SAS?
For this?
Yeah, for that 3 million SAS SSD.
Oh, no. You probably have to check with an IDC and IDC report for that level of breakdown between interface. Yeah. I don't have that particular breakdown prepared here. So this is just to give you a snapshot of how many just kind of an idea about how many SAS devices are sold in the most recent full year, 2017. Any other questions? Okay. So the more common use cases in the data center, probably the most common one is going to be the storage area network. You have SAS AFAs that are connected to Ethernet or fiber channel switches connected to servers going out to the larger network. In another probably, that it was maybe more common, a few years ago, which was kind of a direct attach model where the AFAs were connected directly to servers. Kind of maybe, I think Microsoft Storage Spaces had a configuration like this, kind of a small cluster. And in this case, the SAS AFAs were directly connected to the servers as opposed to switches and then connected to a storage area network. And just a little bit closer look on the inside. This is where you'll see a little bit of the differences between SAS and NVMe and SATA. So starting on the inside here, you have your SAS SSDs connected to some sort of backplane, and that backplane could be a passive or an active backplane. Active backplanes tend to be a little bit more expensive. They'll probably have firmware on them and a little bit more challenging to design. So if you can make it a passive backplane, that would be easier. But regardless, the SSD is going to be connected to some sort of expanders. In a lot of cases, you can have them connected into multiple domains so that you can have fault tolerance and redundancy built in. And the SAS expanders will be connected to SAS IOCs, which in turn are going to be connected to the PCIe bus, and then NICs, and then it going to go out to, again, to the larger fiber channel or Ethernet SAN. And then, of course, if this NIC would be an SAS HBA if it was in a DAS model. Has anybody built one of these? I think some of the older guys, more experienced guys, have deployed these types of. The seasoned veterans have built these types of systems. Some of the DAS. Okay, so I am here on behalf of the Scaling Trade Association, but just as a refresher, what SAS is really built upon. We kind of call these the ilities, the dependability, flexibility, scalability, and economics doesn't really end in ility, but SAS is really built on these pillars, this foundation. And when you think of SAS, you think of reliability, security. It's trusted, it's well understood. It's highly manageable. There's backward compatibility. You have the flexibility of doing SSDs and HDDs, SAS and SATA in it. And it does scale to thousands of devices. I don't know how many, most of the systems, AFAs and arrays are in the 24, 48, and then you multiply them in within a rack. But it has been designed to scale to thousands of end devices. And I think in the end, NVMe is working its way towards that, and maybe not to thousands of end devices, but certainly a lot more than what's typical today. It's actually very well from an economics standpoint. As of today, SAS has the highest capacity SSDs at 16 and 30 terabytes. Those are the largest SSDs that are available today. Provides very good performance per dollar, capacity per dollar. The ecosystem is very mature, and there's a number of suppliers. And that's another reason why SAS and NVMe will be successful as well, because there are multiple suppliers for each component. So, is anybody part of the T10 here? All right. So So just to dig into a little bit more into what's coming in with 24 gig SAS. Now, everybody hears 12 to 24, and they know that the turning of the crank of the speed is going from 12 to 24. Technically, it's not exactly 24 with encoding overhead. It's actually about 22.5 gigabaud. But we're referring to it as 24 for simplicity's sake. But we're effectively doubling the bandwidth of 12 gig SAS. And that obviously will give you higher throughput and better performance. But with that higher speed, you have to have a little bit better error correction. And so we're implementing FEC with enhanced 20-bit error correction. Keeps the signal robust. The data highly reliable and more robust. The enhanced transmitter training algorithm. Before, SAS used to train and make the connection, establish a connection at the beginning when it powers up. But with SAS 4, it's going to be continually being optimized during operation. So it's not just a once and done. From a protocol and block level enhancements, fairness for performance consistency, and this really becomes important as you start getting into larger topologies and mixed topologies. Storage intelligence and persistent connections, those things are very beneficial to SSDs. So a lot of the kind of background tasks can be managed so that you can have better QoS, more consistent latency, and improves overall SSD efficiency. And then lastly, under 24 gig, under the protocol and block level enhancements, SMP priorities, it's just a way to better manage and prioritize connections for deep, complex topologies. So any questions on that kind of SAS overview? Well, that's good. Not sure. Okay. Now for, I'm sorry.
So with 24 gig, are we going to get sort of a native link aggregation protocol as a standard, or is it still going to be a vendor-specific thing?
Are you talking about like Multilink?
And then for the LSI or somebody or whoever took over LSI had to let you run, some 24 gig and some 12, but still get full.
Yeah, I'm sorry, I don't know the answer to that. Did somebody have a comment? I think so. Yeah, I apologize.
Branding for it. There are a couple different vendors. Broadcom has one, somebody else has one. It's kind of annoying because they don't work together. So it was a standard.
Yeah. Well, what's interesting about the standards is that a lot of the things within a standard are optional implementations, so that does leave room for, unfortunately, people to do kind of specific implementations. Okay, from an NVMe, kind of just a quick overview here. It's definitely a lot younger. There is a large, very, very large industry backing. And I think I did ask how many are working with NVMe, and I would say the majority of the hands went up here. So there's definitely a large industry backing for it. Now, SAS is a protocol and a physical transport, and where NVMe is a command set that runs over PCIe. In the case of NVMe OF, it runs over Ethernet fiber channel, IB. As with SAS, NVMe has a very robust roadmap moving forward. for the protocol, as well as NVMe over Fabrics and NVMe MI. Per lane links right now up to 16 gigabits per second. And then the connections are really, it's PCI. It's really kind of designed for internal. So the connection lengths are kind of short, and if you do have longer lengths, trace lengths, then you will need retimers. Typical deployments, servers, HFAs, AFAs, caching tiers. Really, and especially where it shines is when you have like lowest latency applications. And I did say that there are really 4 main SAS vendors where there's a lot more behind the NVMe movement. NVMe is definitely going to be the optimized SSD, protocol, for the long term. And just as a comparison, NVMe, about 4 million drives. The SAS had 3 million SSDs. NVMe is about 4 million. But that number definitely goes up at a much sharper angle up and to the right. Question?
Just to be argumentative, there actually is an external cable spec for PCIe.
Ah.
And at least I've done 3 meters on the external.
Okay. Thank you. I stand corrected. All right. Thank you for that. Common deployments. Well, we just saw this storage area network, but instead you have AFAs here. But with NVMe over Fabrics, this image here happens to be of a disaggregated NVMe OF implementation, where you have the servers and everything is just connected to your top of rack switch. Is anybody working with NVMe over Fabrics types of products today? A few? Okay. Yeah, this is definitely an exciting area, and this is still definitely in its infancy, and looking forward to seeing some good products come out. So this looks a little bit different on the inside. Of course, the NVMe SSDs are over here on the right, and then again, I didn't put it in here, but the backplane could be a passive or an active, and the drives obviously are connected to a PCI switch as opposed to an expander. And then you got 48 lanes coming out of the CPU to the PCI bus, and then you have your NICs connected. Fiber channel Ethernet IB connectivity is most common, and I think the NVMe over TCP obviously is going to help make this a lot more of a reality more quickly. And the only comment that I had here is NVMe Enclosure management is not quite as mature as SAS, but it is. SAS has been around and hardened for decades, and NVMe will get there. And the spec is definitely getting a lot of work put into it. Then a quick look at the NVMe value proposition. Again, large industry backing. Your customers will have multiple sources, so there's no sole source environments here. It's optimized for flash, which was nice to be built up from the ground up for that, as well as next generation non-volatile memory. Lowest latency, high performance applications. Now, interestingly, an AFA bomb, if it's a smaller deployment, would actually be cheaper than say a SAS environment, since in a SAS environment you'd have the additional need for SAS IOCs. Large topologies are going to require larger switches, and since each SSD, NVMe SSD takes up 4 lanes, and if you have a 48 lanes coming out of a CPU per CPU, you'll have somewhat of a constraint if you have 4 lanes going to each SSD. Where in a SAS expander, it would just be a 1-to-1. Best for high performance storage tiers, kind of a tier 0, maybe tier 1. And then the form factors and performance variations really span the gamut for the data center, from the client devices to kind of your scale-out data center and enterprise. Okay, and then on to SATA. This one actually be a little bit simpler in a lot of ways. SATA is older than NVMe and younger than SAS. This is probably the biggest thing here, is that the SATA roadmap has a performance that caps out at 6 gig. No further physical layer plans or roadmap plans in place. Internal cable lengths up to 1 meter. Your common deployments. Now, in an AFA or enterprise server, SATA devices, again, are commonly behind a SAS infrastructure. That's one of the benefits of having a SAS deployment. But because of the economies of scale, 50 million SATA devices shipped in 2017. That's probably 4 or 5 times that of SAS or NVMe. So definitely a lot more than being shipped. They have greater economies of scale, obviously because they are cheaper. So in this diagram, I didn't have to do too much to it. It looks an awful lot like the SAS. And that's, for obvious reasons, is that in a multi-drive environment that's going to be sitting behind SAS expanders, SAS IOCs, and but unless you put like a dongle or some way of having, putting in dual ports onto a SATA drive, then if you don't have dual ported SATA drives, the dongles put on them, then it typically looks like this. You just have a single point of connection. There's no redundancy, no fault tolerance at the same level as you would of SAS. But you would have a connection. This is your SAS infrastructure, and you can see why it would be a little bit on the cheaper side. So the value prop, okay, it's cheap. SATA is cheap, but SATA is going to be going away at some point. It does have the lowest power consumption, leverages SAS infrastructure. Similar to SAS, it supports SSDs and HDDs, but it's not going to, it's going to have that long tail. Because legacy systems, people have already built everything, it's going to be around. Okay, so charts like this tend to cause controversy, but I'm not meant to trying to cause controversy here. So, there's going to be cases where SAS is better, some cases NVMe is better, actually some cases SATA is better. High performance, a typical deployment here. If you did a one NVMe lane to a one SAS lane, you'd have a different discussion than you would have NVMe. A common deployment is a 4-lane SSD that is going to go into an array. I don't know if anybody's building enterprise drives that are by 2 or by 1. So, but in its common deployment, SATA is good. It's a hell of a lot better than a hard drive. SAS is a lot better than SATA. So, here's 75,000 IOPS. Here's 300 plus thousand IOPS, and then NVMe is 800 or higher thousand IOPS. Read latency. Well, we know that NVMe is really designed around that. So the NVMe is definitely going to have the best read latency. SAS and SATA are both good. Read latency is not that much different. You can probably find cases where SAS is a little bit better. but generally speaking, they're similar. But from a scalability standpoint, SAS, that's where SAS definitely shines. NVMe is good and NVMe over fabrics and will help enable that. But as of today, SAS is definitely the most mature and has the most scalability. SATA is actually a little bit better than NVMe because it leverages the SAS infrastructure. Now the power per drive, SATA has the lowest power per drive. SAS is in between 9 to 12, and NVMe is up to 25. Yes, I know that SAS NVMe drives can go down to, they can even go down to single-digit watts. But in an AFA, you're going to be using something that tends to scream. It's a 2.5-inch form factor, good capacity, and those drives are going to be 14, 18, up to 25 watts. Flexibility of the implementation. NVMe is definitely good for SSDs. SATA is a little bit better because it can do SSDs as well as hard drives, and then of course SAS does that for SAS and SATA. Manageability, NVMe has a spec. That's definitely, it's being worked on. It will get mature, it's just not there yet. And SATA leverages the SAS infrastructure, and of course, SAS has been around for a long time. Reliability, SAS is known for this. NVMe, and with things like the forward error correction, SAS is has a little bit, is still a little bit ahead in the reliability standpoint. From a system cost standpoint, obviously we know SATA is going to be the lowest. NVMe still is going to carry a premium for a little while. There are some drives that you can probably put into a moderately priced, kind of lower performance NVMe AFA. That'll still give you really good performance at a lower price. But the common deployment, again, I'm trying to talk about the common deployments of today. So SAS is going to be in between NVMe and SATA. And the last thing on here is roadmap support. We know that SATA is going to be very limited in its future. There are some other types of enhancements going on, but it's not going to be at a performance improvement. NVMe and SAS have long-term roadmaps into the foreseeable future. So we definitely see this as kind of a two-horse race. And I think I said not too many people developing SATA-based arrays, from this audience here. There's that comparison. Any questions on this? Yes, sir.
I'm surprised you didn't include RAID capability. Does that fall under reliability?
I mean, if you look at RAID as an external implementation to the drives,
I think that's one of the big issues that we've got in the NVMe right now is there really isn't great RAID solutions like we have with SAS.
that's a good point. Yeah, SAS RAID solutions for NVMe are a little bit thin today. And I guess it also depends on your type of deployment, where if you're doing something, you potentially could do it at a software level or just have replication instead of doing RAID, depending on your deployment. But you are correct. There is greater RAID support for SAS, actually, as well as SATA, than NVMe is today. So yeah, you probably put that under the reliability.
But whenever you have a new interface, okay, it's going to take time to get it.
Oh, I agree.
There are reliable, NVMe over fabric RAID product today that's been introduced and been running as reliable as SAS. So we're going to be careful with,
We're
because this is a
mixing front end and
new protocol that takes time to.
I agree. Yeah, we're not saying it's that there's no solution. We're just saying that SAS probably has a more mature solution, has been around. So, how long have you been in this industry? Were you at Ingenio?
I am back from NCR.
Okay, so
So that the thing is,
Fantastic. Yeah, I mean, there are, but I'm not saying that there aren't any. Any other questions on this slide? Just going to get through this a little bit quicker. In summary here, SAS is modern as well as mature. I don't want to use the, legacy comes to mind a lot, but legacy has kind of a really old stodgy connotation. But SAS is tried and true, has long roadmap ahead of it, highly scalable and flexible. Has anybody heard of something called value SAS? So, okay, a couple of people have, and one of the reasons I'm saying is that, I happen to work at Toshiba. There is a new class of drive that we did announce that gives you similar pricing to SATA for SAS SSD. So that may help further cannibalize some of the SATA demise, I guess. And believe it or not, there are some 24 gig SAS products that are in early sampling today, kind of more definitely in a test environment, and we're probably looking around Q2 to Q3 of 2019 for a plug fest for 24 gig SAS. NVMe is, it's still relatively new comparatively speaking to SAS and SATA, and I think we expect that to be the long-term SSD interface. It is definitely built from the ground up for flash. So we see that. We acknowledge that. We're not trying to slam NVMe, even though I'm with SAS. It's because of the trade association. Very active deployment, long-term roadmap. And then, of course, there's additional specs in development for network storage, NVMe or fabrics, of course, as well as management. And probably the last message about SATA is that it does not have a future roadmap. It'll have a long tail, but we don't expect that to be a long-term solution for AFAs at a minimum. So that was a little bit quicker than going over. So I can open up for questions. They didn't even hit the 10-minute mark.
You mentioned value SAS. Tell us a little bit about that.
So value SAS is a new class of drive that has probably the main difference is that it does not have dual port. So it'll work well as a replacement for SATA in servers or in some low-end implementations for arrays. Cost-wise, it was designed to be around the same price point as SATA, but it'll give you more robust, better management, better performance than you would get out of SATA drive. There are a number of NVMe drives in this same kind of class as well. So between SAS and NVMe, kind of squeezing out SATA. Yes, sir.
So you mentioned this value SAS. So LSI, all the companies, they used to have that interposer a long time ago, that cost like $30. You can hook up that interposer to a SATA disk, and you can convert to a SAS. Can that interpret your value SAS? It's like an interposer plus SATA.
It's
That's different.
This is not an interposer solution. This is actually a SAS controller developed specifically for this class of drive.
Interposer also has the SAS controller, right? So essentially, it's a single port. Value SAS is also single port.
Yes. So do you have? Did I address your question, or do you have a?
I think essentially it's still interposer plus SATA. Maybe you're
No. It's not It's not a SATA drive that's converted to a SAS drive. It is truly a SAS drive. We just defeatured some things. to help take the cost out. And of course, when you get down to it, the larger the drive gets, and drives are getting larger every spin, the flash is the dominant cost point in a drive. And so with that, the controller cost becomes a little less. And if we're able to design a controller that is less costly, then it becomes more around the same BOM cost as a SATA drive. Any other questions? Who?
Is there a product for that landing sauce?
Yeah, I can talk with you after this, but yes, it has been announced, and we're sampling now. Okay, if there are no other questions, thank you very much for your time. Appreciate it.